Welcome to the real world.
You guys have already spent half the year
It's Nakash.
So we're getting
Where are
into
you?
stuff.
Car trouble.
There's people we're remodeling our balcony right now, and they try to get them to move their car, and I just didn't get it started.
Oh, and it was blocking you in. Yeah. I'm sure you weren't too disciplined.
I didn't get on last night. I'm gonna get on.
Okay.
Ms. Moy, are you touching the screen?
Oh, yep, I am. I don't want you to learn today. You just have to, like, imagine what I'm writing down.
We need to look at the movements of your pen and figure
Yeah.
out.
Okay, derivative of natural log x is 1 over x. That's beautiful, right?
So the integral of 1 over x is also going to be
Natural
integral
log
of x to the negative first.
is natural log x. We'll get there. All right. So if I ask you to take the derivative of log base a of x, a log with a different base. Do you remember change of base formula?
Sometimes.
Yeah.
Oh yeah, that's easy. That's log x over log a.
Yeah, log x over log a, but better natural log x over natural log a,
Okay.
right? So for that reason, the derivative of this is 1 over x times 1 over natural log a, or you can just write 1 over x natural log a.
Oh, that's in section that was useful.
Okay, got it? All right, so now that you know these two, let's take the derivative of a couple things. So natural log 4x is, sorry, I wrote it wrong. So the derivative of natural log is 1 over 4x. And then since 4x is inside of the natural log, you have to multiply by 4. So this actually just simplifies to 1 over x. Which it would work still with log properties. If you expanded this, you would get natural log 4 plus natural log x, right? Yes? Are you
Yes.
with me? Y equals?
Understood.
And then what's the derivative of natural log 4?
That's going to be 0.
This is 0. Yeah, it's a constant, so this is 0. And then the derivative of natural log x is 1 over x. So that's why these two are the same. You can use your log properties, or you can just take the derivative, but it'll simplify to be the same thing because the functions have the same slope. Okay, so this one would be y prime equals, so the derivative of natural log is 1 over x squared minus 3, but don't forget to do chain rule, so we have to multiply by the derivative of x squared minus 3, so 2x. And if you want to do this all in one step, if you're fast, that's fine with me. If you just want to put the 2x on the top. Like this one, if I did it without writing both steps, it would be y prime equals 1 over 3x squared minus 5x plus 8. And then multiplied by the derivative of my inside, but that will just go in my numerator, so 6x minus 5. Bless you. Okay, is it too fast? Okay, numero quattro. Natural log square root x. So the derivative would be 1 over square root x times, and then the derivative of square root x is 1 over 2 root x, and then that simplifies to 1 over 2x. How many sneezes is that?
Too many.
Okay. So an easier way might be to use your properties of logs, because what is this equivalent to?
1/2 of log x.
Yeah, remember you can bring the exponent out in front, and then the derivative of 1/2 natural log x is 1 over 2x. Bless you again. Oh my gosh. I'm allergic to derivatives of logarithms. Okay, now we've got some product quotient chain in here. So 5 would be first times the derivative of the second plus the second times the derivative of the first. Okay. And then you simplify and you get x plus 2x natural log x. Easy? Okay, so you try 6, 7, and 8. See if you get the same things as me. Finish? No?
What? I finished.
Those were my three. Compare yours. Why?
Because the series is on the test and you just did.
I don't get that.
Yeah, me neither.
All right. Questions? Comments? Concerns?
I think that was
You what? I love logs.
Why did we learn the hard way?
Why do we learn the hard way?
I don't think I remember the hard way.
Well, okay, no, this is like, if you took the derivative of this, it would be, so derivative is 1 over square root this times the derivative of the inside, which is 1 over 2 square root this times the derivative of the very inside, which is 2x plus 2. Right? And then that simplifies to 2x plus 2 over 2 times x squared plus 2x minus 3. Because the square roots multiplied together. Yeah, then you can factor out a 2. But I'm not going to. Okay, so the easy way is to simplify this by using your log rules and pulling out the 1/2. and then taking the derivative of that. So if that's my original function now, all I have to do is leave the 1/2 out and then take the derivative of this part. So it's 1 over x squared plus 2x minus 3 times 2x plus 2. So I'll put that on the top. And then it's the exact same as this, only it takes you a little bit less manipulation to do. But if you're not good at expanding or condensing logs, then you might as well just do it the hard way. Okay? All right, try this one. I'm gonna expand it first, so I'm gonna make this 2 natural log x minus natural log 3x minus 2. Because the subtraction in natural log means divide, and then the exponent can go to the front. Or sorry, divide means subtract, and exponent can go to the front. All right, and then to take the derivative, it's super easy. The derivative of 2 natural log x is 2 over x minus, and this would be 1 over 3x minus 2 times 3. So put a 3 on the top. Okay? Easy? All right, try these two, and then I'm gonna try change this one to be, we're gonna do this problem. Okay. So you're gonna have to use, what's it called for this? Implicit. Yeah, I get dy dx by itself.
We're doing the tangent line of y equals 3x plus 2 to the 5x minus 1.
No, we're just going to take the derivative of that last one together. I'll show you how to. I just wanted to give you an example of it. So just do 18 and 19, and then we'll do the derivative of the last one together.
Oh, is this stupidity where you go through writing it in terms of the log?
What'd you say?
I was asking if this was a stupidity where you've been guided in terms of the log.
Use a log to help you? Yeah. It's not stupid though.
It was annoying when they had us just do it for fun doing it.
Get rid of this board guy. I want to show you because it's easy about doing it by hand. You do it on the calculator.
Okay, what do you think, guys? Sorry, this one is covered up. Does anybody need me to go over any of these? Ken, do you need me to go over any of these?
What?
Oh, you were saying hi. Sorry. What? I think it's just, did you go to that academic ceremony? I think that's what it's from. I don't know though. Who knows? Okay, what do you think? All good? All right, let's do this last one that I changed together. So if you have an expression like this, where you have an function to the power of another function, we're going to use natural logs so that we can simplify this. So we're going to take the natural log of both sides. Okay, and then once I do that, now I can bring the exponent down in front. All right, all good? Everybody okay with that step? And then once I bring the exponent down in front, now I can take the derivative with respect to x. So this becomes 1 over y dy dx, because you have to do both sides now since I have a natural log on that side. And then this side I'm going to do product rule. So 5 natural log 3x plus 2 times 3. So I should make that 15. Wait, no, because I didn't take the derivative of that one, just 5. Just 5 natural log 3x plus 2 plus 5x minus 1 over 3x plus 2 times 3. Okay, because I took the derivative of the natural log and it becomes 1 over 3x plus 2 times 3.
Multiply by y.
Mm-hmm. And then to get dy dx by itself, we just multiply by y over. So it becomes 5 natural log 3x plus 2 plus 15x minus 3 over 3x squared, or 3x plus 2. And then all over, and then your original y that you started with, which is this. Okay? Yeah, it's gross. But
Because we could, you don't necessarily have to write it like that, but
oh, it's
more
multiply. It's
complete.
multiply,
Yeah,
not divide.
that's just that it's all.
I don't have room. Because you multiply the y over. Okay. Alrighty. That was was gross. But it shows up a lot on your review and test, so something that you should know. All right, let's go to integrating logs now. You ready? This is where things get tricky. Integration always is where things get tricky. So, integral of 1 over x is, so you know the derivative of natural log x is 1 over x, so the integral of 1 over x is natural log absolute value of x plus c. Now the absolute value is there because 1 over x has a domain of negative infinity to 0 and from 0 to infinity. So if it has a domain of everything except for 0, then it should also have area of everything except 0, right? But natural logs only exist when the inside is positive, so that's why the absolute value's got to be in there. Okay, so we're gonna be able to find area of this function. We just have to put an absolute value in to make sure that every x becomes positive. Now, make a little note that the integral of 1 over x squared is not natural log of x squared. Okay, don't do that because use your normal exponent rules for anything other than a denominator to the first power. So, if I tried to use power rule for this, if I tried to add 1 to the exponent, because this is x to the negative 1, if I tried to add 1 to the exponent, I would get x to the 0 divided by 0. And that can't happen. So for that reason, this is the only integral that you don't do power rule for, you do natural log for. Okay, so if it's any exponent other than 1 in the denominator, then it's not a natural log integral. Okay, all right, so this one, find the following of these 4. Now remember, your properties of integrals, you can bring the 4 out. So 4 integral 1 over x dx is just 4 natural log absolute value of x plus c. Okay, this one is 1 over and then 5x minus 2. So I'm going to do u equals 5x minus 2. du is 5 dx, right? So I should multiply this integral by what? 1/5. Integral 1 over u du now. And then now I can do 1/5 natural log. Might as well plug in my u back in. So 5x minus 2 plus c. All right, 3, u is 3 minus 6x, so du is negative 6 dx. So I'm going to pull out a 1/6 as well as this 4 on the top. So I'm going to pull out a 4/6, negative, right? Integral 1 over u du. And then the integral of that is negative 2/3 natural log, plug in 3 minus 6x plus c. Any questions? Okay. 4, see how it's x squared on the denominator and I have an x on the top? That's a good thing. So my u is going to be x squared minus 4. du is going to be 2x dx, which is great because I have this x dx that matches with this x dx. So what should I bring out to the outside?
7 over 2.
Yeah, 7 over 2. The x dx's cancel, and it's just integral of 1 over u du. And so it's 7 over 2 natural log absolute value x squared minus 4 plus c. Okay. All right, let's do a couple of these together, and then I'm going to have a couple of you, or you do the rest on your own. Let's start with this first one. See how the square root is here? So that is not to the negative first power like this one was. So if I'm going to make u 16 minus x squared, du is negative 2x. So I bring out a dx. Bring out a negative 1/2. Oops, sorry. Bring out a negative 1/2, and then it's 1 over square root u du. Don't do natural log for this because the exponent in the denominator is not negative 1. Or the exponent denominator is not 1. So this you do normal integration of u to the negative 1/2, which would be u to the positive 1/2 times 2. And so then we can go back to negative square root 16 minus x squared plus c. So that's what number 5 should be.
Could it also be an arcsine or an arctan or something?
It could only be arctan if this exponent was just a 1 on the or a number. Okay. Or arcsine. It would be arcsine if this x was a 1. All right. Let's do number 9 together. Integral of tangent is change tangent to, you don't know how to integrate tangent, sine over cosine. So now you will know how to integrate tangent. So we can make u cosine x. Du is negative sine x. Okay, that's going to cancel with this one. So I have negative integral 1 over u du. So it becomes negative natural log, because that's a u, just straight u. Negative natural log and then cosine x plus c. So that's the integral of tangent.
Yeah.
Yeah. Okay. All right. Let's do one more. Let's do 14 together, and then I'm going to have you do some on your own. So 14, in this case, if I see a natural log in my equation, that's what I'm probably going to make u. Because I know the derivative of natural log x. What's the derivative of natural log x? 1 over x dx, which is great because that is right here, right? Yeah? Okay, so really I have integral of 1 over u du now because that other part canceled. And let's change our bounds. Natural log of e is 1 and natural log of e squared is 2. So I just have to go from 1 to 2. And now the integral of 1 over u is natural log again. Absolute value of x, we're going from 1 to 2. Or sorry, natural log of u. And we're going from 1 to 2. These are u bounds, so we can just go natural log of 2 minus natural log of 1, which natural log of 1 is 0, so just natural log of 2. And you can drop the absolute value because 2 and 1 are positive numbers. All right, so I want you to jump around and do a couple, like maybe 1 to 2 on each line so that you get good practice on it. And then we'll go over it in a couple of minutes. All right. So try 1 to 2 on each line.
Blessing in the curse. Yeah. Apparently, every LNX. Well, like most people are.
I just don't think I didn't get it. I got at least one question.
Should we stop by there?
I want to take 2. I'll take 5. Yeah.
Which is great.
Even though I probably also won't.
Wait, can you?
Go back up.
Why did you do that? Why did you explain what the other axis is?
Actually,
I understand what it is.
Okay, so those are the answers.
Why is you know, like the thing where he was like, oh, never mind.
Do you need help with anything?
Can we leave it at 2 LN 9?
2 natural log 9 is fine, but on free response it might come out to be natural log 81, so you, like, I don't know. As long as you know how to get there. Do 13? Yeah. Okay, so make u be 2x plus 1. So du is 2 dx. So I'm going to bring out the 4, and then I'm also going to divide by 2. Integral of 1 over u du. Change your bounds from 0 to 1, and then 4 to 9. So we're going from 1 to 9. Okay. And the integral of 1 to, so this becomes 2 natural log absolute value u from 1 to 9. So it's 2 natural log 9, and then natural log of 1 is 0, so I'm not even going to subtract it. And then that equals natural log of 81. Down. Which one?
That's an algebra.
This one? Because you make u tangent. And then du is secant squared. And if your du secant squared, that's 1 over cosine squared. So that cancels. That one. So all you're left with is 1 over u, and then you integrate it. Renee.
For number 13, if you said like 2 ln 9 or
Yeah, this is totally fine.
okay, so it doesn't matter which variation, or if you put like 4 ln 3.
No, it's yeah, that's totally fine. The only thing is, like, on multiple choice, be able to convert each one, because it's going to give you one of them, but not all of them. Yeah. Awesome. Thanks. Here you go. You have the multiple choice. You have the bubble sheet. All right. So now we're moving on to exponentials. So derivatives of exponential functions. So the derivative of e to the x is not exciting.
All of this is the next standard.
Yeah, it's,
Okay.
it's e to the
one and a
x.
half. It's just gonna be like one of these things.
What the heck a derivative?
Yeah.
What?
This is how bad I am at math.
What? What's wrong, Ken? Oh,
What's
Ken.
the derivative?
Is this why they really like e to the x in like finance? Jackson, my glasses are low.
Yeah.
Get my grabbing
I don't want to.
Well,
Are they?
And they're probably already destroyed.
It explains a lot of naturally occurring phenomena. This is natural log, but that looks like an H, doesn't it?
I think he's totally.
What's wrong, Ken? Is Ken dying?
I am
A little bit.
Nothing is going the way I thought it was.
Yeah.
What does not put me
Yes, boy, why is derivative e to the x e to the x?
Because the slope is equal to its y value at every single point on the line. On the
That's
curve.
insane.
Go figure why it doesn't work.
Can you prove
Is
it
that
for
the
us?
only
Yeah.
derivative identity?
Because it's an exponential function, so it's going to be positive. And then as your exponential increases, so does your slope.
That's my. It's just the only
slope
differential
Slope.
identity.
Yeah.
Along with the y.
Yeah, exactly.
Is e to the x the only differential identity?
Yeah.
Yeah, it is. That's why it's special. Okay, so now when you have, anytime you have like x squared, then take the derivative, x squared, then you can take the derivative like 2x minus 1. But if you see like e to the x, don't do x e to the x minus 1. This is very bad and very sad. Okay, so an exponential function, you never just subtract 1 from the exponent because that's the thing that's variable, that's the thing that's changing, so you can't do power rule. So if you have like 5 to the x, which we have down here, then you can't just subtract the exponent by 1. It's an exponential function, so all exponential functions follow these rules. Okay, derivatives are not too bad. This is just e to the, and then, so it stays the same, e to the 5x. You just have to multiply by the derivative of the inside. So it becomes, a lot of people just write 5e to the 5x. Shh, guys. It's rude. Okay, the derivative of this is 4e to the 1 minus 2x, and then you have to multiply by negative 2. So this becomes negative 8e to the 1 minus 2x. So taking the derivative of e, you just leave e there. This one is e to the x squared minus 3x minus 1, all times 2x minus 3. Not too hard, right? And this one is
Like this.
times 1 over 2 root x. Because you have to multiply by the derivative of the inside. Okay. Let's do the bottom 3 though, because these, I'm going to let you use these for practice. But we're going to do the bottom 3 together. So this is 5 to the x. So all you have to do is do 5 to the x, natural log 5. You just need to tack on a natural log, whatever your base is, at the end of your derivative. So for 24 will be 3 to the x squared minus 2x times 2x minus 2, and then times the derivative, times natural log 3. Do you get that? Or no? Yes? Okay, and 25, we're going to have to do product rule. So 1 times 6 to the negative x plus, and then the derivative of 6 to the negative x is 6 to the negative x times negative 1 times natural log 6, and then times x. Okay, so let's simplify. to make it look nicer. 6 to the negative x minus, let's put the x in front, 6 to the negative x, natural log 6. Otherwise, people will think that the x goes in the natural log, and it doesn't really. Okay, derivatives should be super easy. So let's wrap up and do integrals of exponential functions. Well, I mean, you can do basically anything we've learned in calculus, but now with logs and exponents. So, integral of e to the x dx is, what do you think? E to the x plus c. All right. Oh, and then do you want integral of a to the x? Is a to the x divided by natural log a plus c. So you just divide instead. Okay. All right, let's do a couple of examples. So this one is u sub, so your u is now your exponent for any exponential. For exponentials, your u is your exponent. So du is 5. So we're going to bring out a 1/5 integral of e to the u du, and that equals 1/5 e to the 5x plus c. But if you're fast about it, you could do this in your head. Okay. Pick one for us to do.
24.
23 and 24. Okay. So for 23, this is ugly, yeah. But what I notice is if I make u e to the x plus e to the negative x, my denominator, what's du? E to the x minus e to the negative x dx. Oh, and that's beautiful, right? Because that's up here. So that cancels with that one. So it's really just integral of 1 over u du. And then the integral of that is natural log.
That is wonderful.
Plug in this back in, because we have an indefinite integral. And then plus c. Although, I don't need the absolute value here, because technically the inside is always positive anyways. Or whatever.
We get marked off.
No, you don't. Yeah. If they don't mark you off, it's like too much. So. All right. And what else did you want to do? 24. See how you had 1 e to the x in the denominator? Distribute it to each one.
Where?
So it becomes e to the 3x plus 2 plus e to the negative x. So if you have one term in the denominator, it's easiest just to distribute and split. And then this becomes, e to the 3x becomes 1/3 e to the 3x. The 2 becomes 2x. And this becomes negative e to the x. Negative x plus c. Okay, one more. Do you want me to do any more? 20?
20.
Okay, what should we make u? Sine of x. I'm doing 20. I mean, I could.
Wait, could you try that?
No,
Yeah,
I don't-
For you?
for this one?
Yeah.
No, I don't
You
want
wouldn't
to.
get anywhere with that.
I mean, if you really want to, we could,
The inverse
but
sine of u, that
Wait, but aren't there series that you can plug in?
we'd have to use some, Taylor polynomials to do that. But I'm not going to do that. What should u be?
It's e to the I thought
1 over x. Someone's with me. Du is, this is x to the negative 1. So if I take the derivative of that, it's negative 1 over x squared. Oh, nice. So this cancels with this one. And then I bring out a negative 1/2. And then the integral of e to the u is
E to the
1 over x
over x plus c.
plus c. Yeah. Okay. Got it? All right, the others you can use to practice, but we're done for today.